If you're a bio or chem student, don't believe that medical school is your only path. As a junior year high school student, everything seems to fly super quickly. Having to cram all of the last minute tests that you have the next following day, thinking about what ECs to add because universities are looking more than just the grades. And then of course, you realize that you only have a couple months left before you have to submit all of your college apps and decide where to commit to. In the midst of all these craziness, many people seem to miss out on contemplating on what professions they actually want to get into or what they actually want to achieve in life, which I've personally been there before, where I would easily fall into the career paths and traditional professions which all of your family and friends are talking about. In today's podcast, we're going to be first talking about some of the unheard cons of going into a medical professional career, as well as then exploring some of Hari's research, then breaking down step by step as to how you can break into a similar path yourself, and then finally talking about some biotech and gene editing trends which Hari has been working on in NASA. And to be honest with you, I am not that much of an expertise in this topic. So Hari, over to you. So Hari, could you introduce more about yourself and how things have been lately?
Absolutely. Thanks, Bosco. First and foremost, thanks for having me on the podcast. I'm a bioengineering and business major at Cal, currently in my junior year, studying under the Management, Entrepreneurship and Technology program, so MET for short. We get a dual degree in both an engineering discipline, in my case, bioengineering, and a business degree in 4 years. So a little bit more about kind of my background and my interests. So I got into biotech primarily because I was super passionate about it from a young age. I was really interested in the biology side of things, wanting to kind of help people, wanting to be in healthcare from a really, really young age, seeing kind of family members go through different diseases, seeing friends and family kind of suffer through cancers and autoimmune conditions and things like that. So for me, that was kind of ingrained. And so growing up, I used to joke, but also be really serious about kind of going into pre-med and started off wanting to be a orthopedic surgeon, knowing hearing things about how when I was young I had a pretty nasty fall and broke my right femur, and the orthopedic surgeon who treated my injury was really kind and very, very open, making sure that my mom felt really safe throughout the entire experience, right? And so for me, I started off kind of hearing those stories, and I was like, I want to be an orthopedic surgeon. That guy sounds cool, right? And then it kind of went a little bit different from orthopedics over to neurosurgery at one point, and then more pragmatically over to dermatology as a interest point. And I think when I went over to high school, that's where like I got a chance to shadow a dermatologist, and that's where I really saw the effect of like biotech, right? Where he was kind of using a lot of technology to augment his clinical practice. And when I saw that, I was like, okay, this is what I want to do. I want to build things that have impact to doctors. I want to be able to leverage my technical background, and I want to be able to kind of work at the intersection of biology and technology. So since then, I've kind of worked on a bunch of projects, interned with a couple of companies, most notably NASA, and then kind of went through that process. And now at Cal, I'm doing the same, but with a little bit more of an entrepreneurial focus on how do I kind of take what I'm learning, what I'm trying to build, and also put this spin on it of how do I sell it to customers and how do I make real world impact. So I think that's in a nutshell a really quick overview.
Awesome. I think it's super inspiring how you're trying to mix in tech with bio, because most people, they will only go for bio or they will go for like a specific area, which we're going to definitely dive deeper later into all the AI implications that you're doing. But
Mhm.
just questioning more about your childhood, like you mentioned that you've taken a look at multiple different special fields like neuroscience and stuff like that. So what was your process on skimming through which one you liked, or how did the things that you've done in the past help you decide?
Absolutely. I think it was a little bit of evolution, kind of, but also a little bit of exploration, right? Um, I was fortunate enough that in high school I had the chance to really explore. I was part of kind of the COVID-19 high school experience, right? And so, initially when I started off, kind of freshman year of high school, I got this chance to shadow this doctor, and I was able to kind of through that experience learn two things, right? The first was the doctor I shadowed was incredibly talented, and he was someone who was working out of Stanford, got the chance to really do a lot of, excuse me, got a chance to do a lot of really cool treatments, but he also was very much a self starter. And when he recognized that, eczema, the common condition, was a twofold disease, right? So he realized that most times what happens is bacteria goes and sits in crevices of the skin, like in pockets kind of chapped and broken up skin, but it creates this thing called a biofilm on top. And in order to break that biofilm and really reach the bacteria inside, he designed a two-part, a pretty simple um, kind of treatment. All he did was add Purell to the top to destroy that biofilm, and then whatever cortisone cream he was prescribing to patients could go to sit in pretty deep. Seems simple enough, but you wouldn't know how many people really came up to him and were like, this cured my my son's eczema, right? This kind of really helped, and so he ended up starting a company based on that drug, and he's the exclusive kind of manufacturer for that, right? And patented it. Patented actually quite a few technologies, I believe. And so it was a really cool experience to be able to shadow him, because I was able to understand that, hey, look, there's this entire other realm uh, of medicine that I could be a part of that really kind of shapes how patient lives are led, right? And that was the part that I really wanted to be part of, right? More so, even sometimes more so than diagnosing the disease, is treating the disease, and that was what I was really passionate about. And then fast forward kind of into the different realms, right? I got a chance to then go and do some research into haptics and wearable devices. I got a chance to go do some research at NASA, where I was working on kind of chemical informatics. And I think each experience really opened up new perspectives, right? The first experience was like, oh, this is a lot more hands-on, more mechanical. I was doing robotics at the time, so I wanted to really do something that involved being able to tap into those robotics experiences, but also being able to tap into a new kind of biotech related field. And haptics seemed like it was something that was kind of in that middle area. I really liked it. I think it's definitely something that going into college I was really passionate about. But I think the more I worked with NASA and the more I got a chance to work more computationally about data visualization, uh, seeing kind of machine learning techniques be used for biosciences and for biotech. I think I eventually realized that that's where I wanted to be, right? I wanted to kind of work in genetics and genomics, because that was kind of the thing that really inspired this entire process, seeing kind of the oncology, seeing how oncology, specifically different types of cancers, affected family members or friends in different ways. And so I was like, okay, look, if I can get myself in that field, that would be ideal, right? So it was a lot of like just jumping through different fields, testing them out, but then seeing really realistically what my vision was for where I wanted to be. And I realized that vision was like work kind of going down into genetics and genomics, wherever that is, but hopefully kind of navigating that over to radiation therapies, over to understanding cancer treatments, and eventually understanding immune system responses as well. And that's where I've kind of worked over the past couple of years.
Mm. I think hearing that really made my brain explode. And for anyone who's listening, their brains are probably explode with the stuff that you've been doing. So like if we just break it down in like more of like a micro step and step by step for someone who's like, oh, I want to explore biotech. How did you like outreach to these institutes to get experiences? As you know, it's super competitive now with everyone having their own startups and everywhere. So like what is your approach and what is your advice for like this situation right now when it's not COVID-19, it's just like regularly competitive?
Sure. I think the best thing to do, and this is just general advice, not even for biotech. I think the best thing to do is to kind of cold email and really look at how you can add value, right? I think that's the important piece of the puzzle is being able to understand how do you can add value meaningfully, right? So normally when I look at things, I'm like, when I reached out to this doctor, right, he happened to be someone who was referred to me by my doctor. I'd gone to her and I was like, hey, do you happen to know anyone who's a specialist across the Bay Area who'd be happy to have like a high schooler shadow them, right? It doesn't even have to be in office. We can just, like, if I can just shadow him in the back office or get a chance to go speak with him once a week, that would be great. And so she referred me to this doctor. And so that was a cool experience, right? Same thing, like kind of going and identifying research opportunities. I went and I cold emailed a professor and I was like, hey, do you want to join, do you want high school interns? I'd love to join and just learn more about what you guys do, right? And so that was another cold emailing experience where I just shot an email, hoped for the best, and then eventually heard a response, right? But on top of that, like I think a lot of the summer programs I did again were just I went ahead and sent an application out and really had that conviction to say, hey, look, I'm going to just shoot my shot to a bunch of places and hopefully I can hear back. And I did end up hearing back, and it was a little bit of right place, right time. But I would just say like shoot your shot, send a bunch of things out, um, keep cold networking because eventually you will get something, and you just have to keep putting yourself out there in order to be able to do that. And then on the add value side of things, once you do shoot that shot and you get a response back, try to ask them, hey, what is it you're looking for, right? How can I add value? If I'm a high schooler, I don't really have too much experience, but I can definitely, like, listen in. I can take notes, right? That's something that's a little underrated, but a lot of times, like when I reached out to researchers or when I reached out to people, I was like, hey, look, I'll just take notes. I'll compile all of them. I'll write an article and I can send it to you for review. And I'm happy to post this on a Medium page, or I'm happy to do a blog or a podcast, right? Like just things where you can kind of say, hey, look, I will share your experiences to the world or otherwise. So what you're doing is also indeed kind of down that line. And so I can see that there's a lot of value with that, right? And that could be something that people can just kind of get a lot of insight from. And so I think ultimately that's what I did, was I just kind of looked at opportunities that I could kind of go in, learn from, but also kind of tell those people, hey, look, maybe if there's anything I can do to help, I'd be happy to help, and kind of do any of that you need me to do, right? And eventually that kind of led to, hey, like I'm scribing for this doctor, or um, and I'm learning from him during these one-on-one sessions about how to kind of how he kind of does things, and then I wrote an article on it, right? And then it was kind of like, oh, I'm working with this lab, or I'm working on this research project. I'm going to write a quick article on that research project, right? And the more and more I did that, the more and more I got to kind of continue understanding, building my skill set. And then same thing with startups as well. Like the first startup that I got a chance to work with in high school, I met at a volunteering event, and I just gone up to him and was like, what you guys are doing is really, really cool, right? I just wanted to learn a little bit more about what you guys are building, so on and so forth. And apparently, I talked eloquently enough that he was sold. And so he was like, you should come by and visit our headquarters, and would love to like talk a little bit more about what we are building and how maybe you could help. And so I went and I kind of got a chance to go talk to him, ended up working on a couple projects, and then eventually it was really fortuitous because he ended up being a mentor and a really good individual for what I was trying to build. But he also went through a pivot, and so I got a chance to really understand what it means to pivot a product, right? And how he was kind of looking through the entire AI landscape, where he made changes. So ultimately, that one was where if you really know the right questions and the right things to ask a founder, right, you can definitely be on the kind of ground helping them deploy and helping them scale.
Yeah. I noticed like one really large trend amongst all of the experiences and stories that you've shared is literally you're just actively reaching out to the people. Like there's really
Hmm.
nothing that unique. But I remember like last week or a couple of weeks ago when we first chatted, you mentioned something really interesting about your college applications where you took like a really
Hmm.
unique approach where you actually went to the school itself, like took a photo of like different places and then used that as one of your essays. So
Yep.
just furthering on that, like what are your top three values that you think you personally like really have that makes you stand out from other applicants?
I think, and this goes back to kind of the childhood question as well. I think for me, it was always uh, be useful, be kind, and be like technically deep. Those were three things that kind of my dad used to repeat over and over again when growing up. He was like, "Look, be kind is pretty straightforward, right? Be a good human being. Go out there and always add value to people, and don't really expect anything in return, right? Just go out there and be a good human being. Be a good friend to people, right? If Be someone who people can support." And so I've really taken that to be something that I take to heart. And whenever I go and I look to add value, I'm never expecting anything in return, right? Like I'm going in and I'm saying, hey, look, if I can help a person, if I can help a founder, if I can help my research group, uh, and help make the world 1% better, then I'm going to take it, right? Be useful, right? Don't just say, hey, look, I'm going to help people, but then you don't really know what you're helping them on. And so you're kind of going there and and then saying, hey, look, I'd love to help, but I don't really know what's going on here, right? Like that would be bad, right? That would not add any value to anyone, but instead it would actually subtract from your from people wanting to work with you, right? So be useful, add make sure that you identify a problem that the other person is having, and figure out how you can use your skill set to help deliver value and really and address that problem for them, right? And I can give you a couple of examples of that, right? um, when I kind of went to uh, when I went to NASA, right? Well, what I realized was that, hey, look, we're building the first kind of high school internship that I got a chance to do. Right, we were working on this project where we had to analyze these gene sets, and we had to basically go through this entire I think it was a multi-step process that they gave us this handbook for. And so we had to follow that handbook and perform the entire end-to-end sequencing, reading, filtering, and then eventually doing the visualizations on that data. But it turns out that when we got started, there were some errors with that specific data set that we were working with, where the templates were a little bit weird, right? And so we were working on it, and then we realized that, hey, we can't really work on this right now because we were in this kind of weird state of limbo where we needed the templates to be fixed in order to for us to kind of move on with our with our analyses. So we had about an hour where we were just kind of waiting. But instead of making that hour useless, right, what we did was we tried to be a little bit useful and said, okay, what do we need to get done in order to really be able to work faster, work more efficiently? So that 1 hour became a brainstorming session of us just planning out the next couple of days, right? We were like, okay, we have this data set. What all do we need to get done with it? Well, we need to test multiple different factors. Well, what factors do we need to test, right? We need to test the control, and we need to test the spaceflight group for this NASA space biosciences experiment, right? Well, what spaceflight groups do we have? We have microgravity, and we have simulated gravity. And so if you know anything about space experiments, they always have one thing that's in microgravity, one thing on Earth, right, which is your ground control. But sometimes they can also have a couple of other different factors as well. So this particular experiment had a simulated gravity condition where they were spinning the mice in a centrifuge. And so we got a chance to kind of test out all three of those, right? And so we basically made this plan to say, okay, what we're going to do is we're going to create a team name, we're going to create a team email address, we're going to share that to every single member of the team, and then we're all going to log into this platform through that shared team on off times or on times where we're all working together. And we're going to make sure that every single one can work in parallel, right? And instead of working sequentially, right, we worked in parallel. And and when I was working on, for example, one of the factors, my group partners were working on the second factor, and we had one member who was kind of spanning both individuals to make sure that all of their steps were being done perfectly. And at the end of it, we had actually kind of, even though we started an hour behind, we were on par with everyone else by the end of the day, right? And so just that 1 minute of kind of thinking about, okay, we have a problem, but how can we be useful and how can we solve this problem in a logical way was a game changer. And then finally, like being technically deep, I think is a little self-explanatory, right? But it's like being able to have that depth of understanding, being able to go really deep into what you're learning, right? So with biotech, I've kind of found my niche a little bit more with computational biology, and now it's a lot of like data visualization, data management work for biology. Uh, with a little bit of AI, I've started working through applying AI to what I'm working on right now. But that's become my niche, and that's become a place where I've really started to grow and learn. But just having that technical depth in one vertical is very important. And so I think those were the three unique values that I add: be useful, be kind, be deep, and that's really helped me a lot.
Awesome. I actually just wrote that down, so I'm gonna remember afterwards. So like,
Absolutely.
speaking more about like that last point, like that technical depth, I'm probably assuming that you're talking about like specific knowledge, like you need specific knowledge in a
Absolutely.
certain. So what's your general take on also having general knowledge itself? Because, there's this whole debate whether or not you should have special knowledge in like certain fields or a more general knowledge where you can apply stuff in different ways. I'm pretty sure many people hearing this will already know what we're talking about. So what's your approach based on all of your experiences in like Berkeley and being like the student president, like learning about so many different people? Like where do you stand in this?
Absolutely. I think broad versus deep is a very important conversation to have. And with biotech, it's interesting, right? Like when I came into Berkeley, I had this business degree as well, right? So it was kind of like, oh, I'm doing biotech, but I'm also doing business. So I got this chance to really be a little bit uh, spanning both of them. So for me, I found myself for kind of the first 2 years that I was at Berkeley being a little bit more broad, right? Because I was trying to explore the business degree a little bit more, explore the bioengineering degree a little bit more. And then I kind of found out that, hey, look, these are the places that I really liked. In business, I really liked the ability to kind of strategize, be on the lookout for different trends, do market research, right? And otherwise. But on the biotech side, I like doing research. I like looking at computational tools. I like to be able to build those tools for people and work in data visualization. And eventually, what I found was that both of them are relatively similar, right? It's like the idea of performing regular research still requires a hypothesis, right? Requires you to test that hypothesis over experimentation and then be able to augment or change your initial hypothesis if necessary, or kind of come up with some type of conclusion, right? Well, it turns out that when you're doing business strategy, you're kind of doing something similar, right? You're coming up with a hypothesis for where you want the company to go. Then you're doing all your research, you're experimenting by actually building the product and getting customer validation for it, right? And that's your experiment, right? You're testing with customers and you're going back and you're iterating the product if a customer comes back to you with, hey, this isn't working out, or this here's a product feature that I'd like to be added. So you're doing that active testing, and eventually that leads you to a conclusion of, hey, my product works or my product doesn't, right? And so I realized that like there's a lot of overlap there, and then that's how I was kind of able to specialize and say, okay, I took this kind of broad overview of what interests me in biotech, and then I said, okay, the way to filter that by one is which concentration in biotech interests me. Well, okay, we established that that's computational biology. Okay, which part of computational biology interests me, right? Because computational biology could be applied to medical devices, it could be applied to tissue engineering, it could be applied to genetics and genomics. So we established that, hey, look, I'm interested in genetics and genomics. So you keep kind of making those filters and you keep bringing yourself further and further into a niche. And I think that's how I approached finding my own kind of niche, was being able to essentially start off broad and then go one at a time. Now, I think if you go to a different college, right, you may kind of find yourself at that niche a lot faster. Sometimes you may find yourself at that niche a little slower, but I think it takes time, and I think at the end of the day you can kind of find that out only when you really test for yourself and really work on projects that allow you to do that. So I think for me, when I came to Berkeley, I started working on a couple of projects of interest, right? And one of them that I'm currently working on is like an AI physical therapy assistant, that leverages kind of my experience with physical therapy as a patient to say, oh, how do we kind of go through and augment the process for physical therapists to make it faster, right? And that's something that I'm currently working on, where I think about kind of the entire pipeline from end to end. I'm using and leveraging my background in data analytics, but I'm also using and leveraging the background of business to understand my customer and understand what they want and how I can augment their lives to make it better, right? So ultimately, I would say take the take the depth from being broad a little bit, right? Like use your breadth to explore different fields, use your depth to go deep into one field, right? And essentially, like in the process, you would create something called like a T shaped individual, right? You're broad at top, but you're deep in one vertical. And I think that's very important to have that technical depth in one vertical, but also be broad enough that you have some flexibility to move around and really understand things. And in biotech, that's pretty straightforward to do, especially given that everyone wants to do AI, right? But if you can do like, hey, if you can say, hey, look, I'm going to apply AI to different parts of biotech, then you'll still have that flexibility to say, oh, now I've really specialized in AI for bio, right? And then you can kind of apply that to different parts of biotech and people will be cool with that, right? But your specialization is AI for bio, or your specialization is uh, building devices. Well, you don't really need to worry about which part you're building devices for, right? You could be building haptics, you could be building prosthetic devices. There's still enough flexibility within that domain of building devices that gives you the opportunity to still explore, but still be deep enough that that becomes your niche and that becomes your story and your personal brand.
Mhm. What's your take on having side projects? So, for example, what I mean by side projects is like projects that are outside your industry. So, for example, like you're doing biotech right now. What if like there's this interesting project in like music? Like,
Mhm.
like more specifically, like how do you balance between opening up to like new opportunities, which may like blow your mind, versus like
Mhm.
locking in into like a specific thing? Like, do you have like a self system that you use?
Yeah, I think for me, it was always, I think it's just finding a priority list, making a criteria list of what interests you and how much time you have for it, right? So I think for me, I always say, hey, look, go seek out your personal like side projects, because some of them might be really interesting, and you don't necessarily have to be the world's leading expert in that field in order to be able to build in it, right? And so, actually, fresh out of high school, I had this um, project that I was working on for a CS class that ended up kind of being something that I was really passionate about and I was really interested in. And so, the project was called One World, and what we were trying to do was build these high altitude imaging analysis platforms. So, looking at kind of images shot by drones or by satellites and seeing if we could glean information about damage assessment, right? So, we actually built our own little AI model, and we were basically looking to test the damage levels of different buildings uh, within a given radius. And we could kind of tell you, hey, is your house like prone to earthquakes? Is it in a region that has had several earthquakes in the past, and do you want to? And if so, what is the projected rate of damage, right? And so we could mark that with a red, with a yellow, or with a green. Green being the most positive, and red being, hey, maybe your property is a little bit more closer to potential damage sources. So we started off kind of doing this where we would be able to take images right after like hurricanes or right after national disasters, and we could go to search and rescue teams and be like, here are the houses that were most damaged, here are the houses that are slightly damaged, and here are the houses that were intact, right? And we found that something like that would be super useful, especially with the recent like LA fires, right? Like something like that would have been very, very helpful to kind of understand how many houses were left intact, how many houses were not. And it would give people, it would give search and rescue teams a little bit of a faster time to respond, but it'll give people a sense of peace of mind, right? That, hey, look, they now know these are areas that are potentially prone to damage again, and so this is what you need to do to reinforce infrastructure. So that was a personal project that I got a chance to work on for a little bit. I now would I say I was really knowledgeable when I kind of got into the project? Not really, but I also made sure that I had allocated enough time in my day to kind of work on this, right? So over the summer, I was working on this like 5 hours um, per week, right? And every week we would kind of come in, we would sit down, we would make a plan, and we'd say, this is what we want to accomplish this week. We want to fine tune the model, or we want to call up CAL FIRE and understand what they're doing, or we want to reach out to the Red Cross. And so then we would go during that week, we'd complete all of our tasks. We'd come back and we'd say, hey, in this 5 hour time slot that we allocated for all of us, this is what we were able to accomplish, right? And so we really made sure to have a concrete timetable in place of this is how much time we're going to allocate, no more than that, because we want to make sure that we aren't letting this thing like 100% consume our lives, right? Which usually happens when you're building a startup and when you're making that your main project. But when you're making it a side project, you want to kind of make sure that you allocate enough time for you to really explore the project, but don't allocate too much time to start, to be able to kind of just keep it as a side project, keep it as something that you're doing as a hobby and building skills for. right? And so this was something where we knew like it was more of a research project than something that we're going to commercialize. So all we did was really say, okay, this is a side project that we can work on. We're going to allocate 5 hours. Now, if I was to start a startup based off of that, I think my advice would change a little bit, right? I would say, hey, look, maybe you would want to have a little bit more conviction than just saying, hey, we're going to leave 5 hours in a day to do that, right? Eventually, if you're building this out of a startup and you're committed enough, then you would want to go all in and really be able to take that project to the next level. We didn't have any startup inclination at that time. We just wanted to build something that was really cool and build a research project out of it. So for us, it was more about focusing on like the 5 hours, but making sure that that 5 hours was high quality work time.
Mhm. I mean, like this is such a random thing, but like, well, how's your schedule looking for this week? Like, you can see from my room that it's getting a bit dark here. I know it's probably later for you. You just came back from a retreat. It's like 4 a.m. for anyone who doesn't know that Hari right now
Yeah.
is in the Bay. So, like, do you have like a fixed schedule? Like, how do you operate your days?
Yeah, so my days are fairly flexible, right? I personally realized that going back to your kind of balance question, right? I personally
Mm,
realized that for me, I like to have a bit of a balanced schedule, but I also love to have a lot of free time to be able to do projects, to be able to work on things that interest me. I'm currently working on research with NASA's NASA Ames' Space Biosciences division, and so I needed to make sure that I had enough time within my work week to actually be able to work on that, right? So the way I've kind of set up my schedule for this past semester, spring semester, and also in the fall as well, was that I would not have very many classes on Mondays and Fridays. So I would be able to work on kind of the work on research and then work on personal projects over the weekend and on Mondays and Fridays. And then Tuesdays through Thursdays would be my kind of heavy course load days, right? So I would have a lot of classes on Tuesdays, then most of my discussions and a couple classes on Wednesdays. And then again, Thursday would be a repeat of all of the Tuesday classes. So that worked out really well. My junior fall, I was able to kind of keep track of a lot of the projects that I wanted to work on. I recently got into venture capital a little bit more, so this gave me the opportunity to be able to go deeper. And most of those events typically land on a Monday or a Friday, so it works out that I have those 2 days free because then I can actually go work on those. But it also works out that those are the bookends of a week, so I can go talk to my research mentor and say, "Oh, what do I need to get done for this week?" Right? On a Monday, or typically we have our intern meetings on Fridays. So I would go in and I'd say, "Okay, what do I need to get done for this week?" Then use the weekend to really be able to build out whatever research project or little extra uh, like piece that I need to implement for the project that I'm working on. I'd do that over the weekend. And then I'd come back on Monday and be like, here's my updates, right? I got a chance to work on this over the weekend. Um, Here's what I built, and here's what we can do. And then they give me a little bit of feedback, some more concrete places for me to implement more kind of features into. And then Friday, I present that at the intern meeting, and the cycle repeats, right? So it works out pretty well because then during a week, my mentor would kind of work from Monday to Friday. I will work on Mondays, Fridays, Saturdays, and Sundays. And so I'd be able to kind of see the progress that I'm making. And then it kind of like works in this really nice cycle, right? And so for me, I basically now have kind of told myself that no matter which schedule I take, I try to keep my Mondays relatively free and I keep my Fridays relatively free so that I can catch up on schoolwork. I can work on these projects that really interest me, but I can also work on research or anything else, and that usually gets bounded in the time of Mondays and Fridays. And then weekends, I kind of leave relatively open for these projects that I want to work on, and then for the research that I'm doing as well. But then, with the exception of a few weekends where I can kind of go hang out with a couple friends and be a little bit more open and flexible with that.
I think that's a really efficient system. Like I've never actually heard anyone talk about that. So like thanks for sharing. I think it's definitely pretty
Absolutely.
useful for anyone like hopping into college and thinking about different schedules and stuff like that. So like speaking more about like the friend stuff, like do you have any other systems which I call like kind of efficient system where you kind of kill two birds in one stone? So for example, for me, like every single day, like I need to do some exercise, right? As it's healthy, but then sometimes you also want to meet your friends. So what you can do is you can schedule like you playing tennis, which kills two birds in one stone, where you can socialize and also do sports. Like, do you have any other systems where you kind of do that as well to like save time?
Yeah, absolutely. I think for me, it's usually when I'm meeting new people. I'm like, hey, look, let's meet for lunch, let's meet for dinner, where I can go
Mhm.
get a meal, but I'm also like talking with someone in the
Yeah.
process. And I think that's the fastest way for me that I found to be able to like catch up with people who I might not have been able to catch up with previously. Right? I just go say, hey, look, let's find some time to chat over lunch or go grab a coffee um, or go for a walk, right? I think whenever I'm back home in San Jose, for me, that's my go-to way of kind of just catching up with people is like, okay, I anyways need to go for a walk to get some exercise and just and go from let's say I'm going grocery shopping, and most groceries, at least from the place that I'm from, are about walking distance. So I basically go, okay, if there's a friend available who's also back in the Bay for spring break or something like that, I just go for a walk with them all the way up to the local Trader Joe's to go buy some groceries. But along the way, we're catching up. We're talking about like how our different schooling experiences are going, right? What he's working on for research. Like for example, with one of my close childhood friends, we basically go for walks all the time, and that usually becomes our way of kind of staying connected and talking about like school, talking about interests, passions, research, anything of that sort, right? So that's something that I do a lot of, where I basically just schedule in time into my day, where if I need to meet someone and I know I need to get a meal in for that day, I'm just like, hey, you want to come with me to dinner? Let's find some time. I anyways have a 1 hour time block inked out. I can give you a call, or we can talk, and that usually works out pretty well. Um, but I think in terms of other efficient systems, I think it's mostly like if I'm in a specific location, right, and I need to get to another location, that's another time where I basically am like, hey, look, I'll just give you a call during this just time that it takes me to kind of walk from point A to point B, right? Because anyways, I'm walking from this class to the next class, and I don't really have anything to do, right? And that's a perfect opportunity for me to just go ahead and call someone and get some get their opinions on whatever it is that they want, right? And so it's like that's another thing that I've realized is that you can make a lot of free time for yourself by using existing time that's being wasted right now from like going to from point A to point B. You don't really have anything to do in that process. You can just kind of hop on a call with someone where the call is only going to take like 10 to 15 minutes, right? You can quickly just hop on the call and say, hey, look, let's do this like during this 10-minute time gap that I have walking from class to class. Or let's do this when I'm grabbing lunch. Let's do this when I'm kind of quickly uh, at home, just like getting ready to do something else. But I have a couple minutes. Let's quickly hop on a call before we forget, right? So all of that are effective ways that I've found to balance time, but still make it feel like you're valuing the other person as well.
Awesome. Yeah, I think it sounds like such small things, but literally it can literally make your day because like when you're just self
Absolutely.
studying it alone, then it's not that great. So like speaking about college, just wrapping up everything, what was your top three like biggest moments or biggest challenges that you've personally faced yourself or distractions?
Hmm. That's a great question. I think for me, when it comes to challenges, right, there are really three things that I tell people. The first is like, I mean, finding this balance between classes, between research, between academia, as well, wasn't something that just came naturally, right? It's something that took maybe a year to get situated into and figuring things out. So the first thing that I'd say is like, be open to saying no to things very early on and having a set of criteria that you evaluate your decisions by, right? So, coming into Berkeley and being part of like this really talented ecosystem, right? It can often feel like there's so many resources at your disposal and there's so many different clubs that people are doing. There's consulting clubs, there's research clubs, there's technology, right? Then there's also the whole research scene on campus. There's social events. The campus is inherently vibrant, right? There's something happening every single day. And so you're sitting there going, this is awesome, right? And as an extrovert, like I'm really passionate about being able to be part of this vibrant ecosystem. But sometimes it also gets a little bit like unnerving a little bit, right? Like you're kind of sitting there going, oh damn, like there's a lot of opportunities, but what do I pick? How do I kind of make myself um, stand out, but how do I also find the right things for me, right? And so what I did when I was kind of going through that process was looking at, for example, taking a step back and saying, oh, I want to do one research based situation. And so that's where I found my NASA research to be most helpful, right? I want to do one kind of social club. So that's why I went and I joined the MET student board because I really wanted to kind of build socially. I wanted to give back to a community and I wanted to get in some leadership experience, right? And then I kept and then I told myself, look, I also want to work in venture capital, and that doesn't involve me working in a club, so I need to kind of take a step back from some of the clubs that I'm working on, right? And just kind of do that outside of school. So for me, once I recognized that these are the three areas that I wanted to do, right, I basically went very deep into each one of them. And I said, okay, I'm going to work on my research and I'm going to make sure that my research is as good as I possibly can. I'm going to work on my venture capital and I'm going to schedule events for days that I'm free. And I'm just going to be able to go to as many of them as I possibly can, right? And then for academics, I'm going to make sure that I schedule for office hours and make sure that I go to labs and discussions to really show that I have the time and effort to make sure that I'm doing well in my academics, right? And so making that criteria list and saying, this is what I'm going to achieve, and then being intentional about it. That's number two, right? Be intentional about what you're doing. Don't just say, oh, I'm going to make a plan. And then by middle of the semester, you're like, you know what, that plan, we don't have to worry about it, right? We're well, like things change, I'm not uh, that then what's the point of the plan, right? So be intentional about that plan, be try to really make sure that you're following along with that plan, and if you're not, then understand what's going wrong, right? Like say, hey, look, maybe your plan is wrong, right? In the sense that maybe you didn't like doing that specific thing, right? Maybe that club wasn't for you, or that opportunity that you got, you thought it was something that was really cool. The opportunity ended up not really panning out for you, right? Then understand and document that, and then go, okay, how do I change that? How do I back away from this opportunity and pursue something else, right? So being intentional allows you to kind of take those into consideration and make sure that you find your unique path. And then the last challenge, I think for me, realistically, was just like being able to say no to things, right? Like, so we started off saying find your criteria, be intentional, but then the third thing is like, what happens if an opportunity doesn't pan out, right? you eventually have to say no, right? Uh, but oftentimes, like when you're exploring, you're like, damn, I really want to explore all of this. How do I say no to this opportunity, right? Like this is such an amazing opportunity, really cool. It's going to be able to get me my next internship or whatever not, right? But then realistically, is that just you kind of speaking because you're passionate about it and you're biased about it, or is that you speaking because like that's genuinely what's happening, right? And so sometimes you might be personally biased towards something because you've invested so much time and effort into it without recognizing that maybe it's time for you to take a step back and say reevaluate your choices, right? And so understanding that it's okay to say no, right, and it's okay to kind of reevaluate those choices is very, very important. And so for me, right, like I ended up realizing that I was attending a lot of events that I really didn't need to. Um, there were events on, initially there were events on investment banking that I was attending, events on consulting and otherwise. And in sophomore year, I realized, hey, look, I don't really like I don't really need to be going to some of these IB events or some of these consulting events because I recognize that I was more interested in entrepreneurship and venture capital at the time than I was in traditional finance or in consulting. And so I took a step back. I said, okay, it's okay for me to say no to these events, um, even if like I was a part of one of the consulting uh, wings of my program and otherwise, right? Like I was like, okay, I'm gonna take a step back. I'm gonna say, hey, look, instead of consulting for these companies, I'm going to look to source them, right? Because it's the same skill set that I'll need eventually when I want to go into venture capital is sourcing companies. So being able to have that sourcing mentality under my belt and training that up by sourcing companies for my consulting firm would be good, right? So that's kind of how I decided to reframe things, right? I said, hey, look, I'm saying no to being a consultant, but I'm saying yes to something else, right? But that something else would be a little bit more aligned to what I want to do in the long run than what I'm currently doing, right? So making those small decisions and being able to say, okay, I'm just gonna quit cold turkey on this, right? Reevaluate my choices, and there's definitely opportunities for me to come back, but maybe that when I come back I'll be able to work on something that's a little bit more aligned with what I'm currently interested in. Definitely is something that I would say is some strong advice moving forward, and that's something that I also put into practice.
Like in terms of like the documentation part, like what do you personally like to do? Do you like to do like semester goal reviews, yearly goal reviews, or what works for you?
Yeah, I've done like I normally come in and I say, okay, this is my semester. What worked, what didn't work, right? One of the things that I started doing last year, and I still do a little bit this semester as well, is every week I kind of jot down, okay, what worked this week, what didn't work this week, how do I improve for next week, right? And so last semester I actually had this like little piece of paper that like this notebook that I would write all of this into, and I would say, okay, this is week 7 or week 8 of the semester, right? Here's what worked, here's what didn't work, here's what and for every class I'd go, okay, here's the homework, did I submit it on time, did I make sure that I spent enough time actually understanding the concepts, am I still playing catch up with any of my classes, right? For research, did I have enough time to finish my research materials for the week, or did I need to spend a little bit more time, less time, how was things going, right? How much time did I spend like outside of school? Did I make sure that I balanced my life, or was I just doing all schoolwork and didn't get the time to really uh, uh, just take my own breather, right? And if I didn't, then okay, how do I schedule a little bit more of a breather into the next week, right? How do I kind of and let's say if I had some catch up work that I needed to get done, how do I schedule that into the next week, right? Sometimes maybe that means taking away from time I spend with those breather sessions or like relaxation sessions, and that's okay, right? That's the kind of trade off that you have to make when you're looking at how do you effectively balance time, right? And so I think that's something that really has helped me, and I basically just document by writing these notes in, and and now this semester I'm doing that kind of every other week, and I'm saying, okay, every other week, what worked, what didn't work, how am I doing in classes, how am I doing with academics, how am I doing with career aspirations, and do I still need what do I still need in order to get to the place that I want to be, and then just slowly and steadily making changes 1% at the time. There's a really good book that I recommend people reading called Atomic Habits, where the guy says, James Clear, who's the author, that book right there. Yeah, James Clear, who's the author, says like, look, if you can augment your life by 1% every day, I think the statistic he has is like it'll increase by like 31% by the year, something like that. But it's a drastic improvement. But if you keep reducing yourself by 1% every year, you're gonna hit a pretty strong plateau where you're just going to be inherently worse off, right? So you always want to kind of improve yourself by 1% every single year, or sorry, every single day, so that by the end of the year, you're really way higher than where you expect it to be. And to do that, it starts by kind of understanding your day, and then understanding your week, understanding your month, understanding your year, right? So if you can keep kind of augmenting every single day of the week, then understand that week, right? And if you can keep augmenting every single week, then understand that month. And then if you can keep augmenting every single month and then understand that year, you'll be able to really get a lot more value out of it, right? You'll be able to understand what you did right, what you did wrong. How do you make those changes, like small incremental changes that he talks about in the book, and how do you create those habits so that eventually you are kind of in this rhythm where even if you don't have a specific routine, right, you're still in that rhythm of being able to do things a specific way, and that really shapes the way you kind of get opportunities, that shapes the way you kind of act with other people, and that really ends up becoming your personal brand and motto, if that may.
Yeah. I mean, it's awesome that we're diving really specific into these systems. I actually just thought of your point on how you talked about saying no. And I feel like saying no is definitely one of the harder things that many people face, especially when they got started in our journey, like many young founders
Mhm.
online. So, like, I just
Absolutely.
want to pull this up. This is a framework
Yep, I can
from
see that.
this is a framework from Diary of CEO Stephen Bartlett. Don't know if you know him,
Mhm.
but for anyone listening, he's a very successful podcaster, and he came up with a actual quitting framework where if we just go through like this tree diagram, it's like you can just ask yourself if when you're thinking of quitting, are you quitting something because it's painful or it sucks? So painful is like it's actually painful where you actually don't really like it, or sucks just means that you're emotionally and psychologically not wanted. Painful is like actual like physical pain, right? And then you have
Yep.
two paths. So the first path is going to be for the painful option. Is the hardship worth the rewards and outcome? And if it's yes, then you should don't quit, as you can see on the graph for people who are watching the YouTube video. And for those who are listening, you should probably watch the video because you can see this better. But if you say no, then obviously you should quit. And then
Yep.
for the sucks path here, first path is, do you believe you can make it not suck? And if it's no, then you should quit. And if it's yes, then you can easily navigate your way through and figure out whether you should stay or quit. So I feel like that's another interesting point to bring up. That's another system that I think is very useful for anyone listening to navigate their way.
Absolutely.
But yeah, I mean, like speaking about more on like the MET side, you're obviously the VP of marketing for the MET student board. So,
Mhm.
what are some interesting personas that you've seen so far, or what are some common trends with MET students?
Absolutely. I think so I was the VP last year, and so I had the opportunity to really help out with kind of the admit weekends and things like that. I think for me it's really been this kind of blessing of being able to be part of that community, primarily because there's so many talented individuals in my cohort, in other cohorts, who are able to kind of both be like mentors or be folks who inspire you, right? So kind of when I wanted to enter venture capital, there was this guy Sid Sridhar who was a MET class of, I believe, 24, and so he ended up serving as a mentor, providing us providing myself with opportunities that I can kind of use to build my skill set in venture capital, right? There was also folks within my kind of cohort who really inspired me a lot, right? There was a guy named Ane who was a grandmaster, or sorry, no, international master at chess, and he's just like he just that's something that he was doing in high school, and still continues in college. He also started a pretty hefty business as well. But then there's others who are all building startups. My roommate, who was actually on the podcast, he does a lot with venture capital as well. So there's so many people who are within this like MET program who are all incredibly inspiring. And so I think one of the things that when I was kind of coming into the program, I told myself internally was that, look, I'm the 50th guy who got into MET. If the cohort is 50, if the cohort is 80, like I'm the last guy who got into MET, because for me it's like everyone else is so incredibly cool. There's a guy who's like now working on like travel point systems, and he managed to basically understand how to fly pretty cheap to anywhere in the world. And so one of the things that he basically did was, our freshman year, he tried to book everyone a trip to Hawaii for a couple of days. And so he managed to get it down to pretty reasonable price for a bunch of different perks, like including flights, hotel stay. We even got like a little like yacht to kind of go take us around
Nice.
the like beach, and otherwise all of that was relatively straightforward, like relatively cheap prices. And so it was like half the expected price for a Hawaii trip, right? And so we were kind of sitting there going, wow, this is like, dude, this guy, like without this guy, where would we have been when it comes to traveling that when it comes to planning that travel, right? And so it's just like incredible how much these individuals within the program are really good at what they do, and it really helps inspire you to be really good at what you do. And that kind of goes back to that technical depth point, where like you kind of find your niche and you craft your personal brand, right? I think what MET does is it allows folks to craft their own personal brands and identify what makes them a unique individual. And so we just have all of these unique stories of like people. One of my suite mates from last year is building uh, vertical takeoff and landing drones, which are basically like, so Alan Zhang, who I believe my roommate Shashi mentioned on his part of the podcast, so you can go watch that after this to really learn more about what he does. But Alan Zhang is creating these drones that can take off vertically and then fly to from point A to point B. And he's building different types, and really helping to inspire a lot of students and folks as well. And like you just sit there and you go, this is awesome. Like this is incredible. And yeah, it's really uncommon. And so you see that and you go, damn, he's living out what he wants to build. Like I'm inspired to now go and build something in biotech, right? Or I'm inspired to go and build something that has been on the back of my mind for years, right? And so it's just having all of those people there to kind of support you through that journey, to offer their advice, to be able to be sources of motivation for you, I think is really cool to have in that program.
I think that clears like lots of misconceptions of what people think about the Berkeley MET program. Like I was also looking at the UPenn M&T program, which is East Coast, and I think one of the biggest difference is that Berkeley people, they're all into startups and they all have like specific niche. Like
Yeah.
I'm not gonna say anything bad about like the M&T program, but not all of them would be going on this entrepreneurial track, and they're just trying to go do something finance related or professional later on. So I think that
Mhm.
is something that differentiates this MET program. So out of the top of your head, like, do you think there are any other misconceptions that people think about the Berkeley MET program that you can clear as well?
Off the top of my head, not really. But I think for me, it's like realistically, I think with any program in college, I could say stuff about Berkeley for sure, right? I think there's a lot of misconceptions that Berkeley is a very competitive university, and I'd say, look, on some level or another, every university is competitive, right?
Yeah.
Berkeley is definitely a hard university when it comes to academics, just in the way that things are graded and otherwise. And there are definitely some courses that are a little bit more weeder courses, if you may, that tend to be there inherently to kind of weed out people who aren't really trying to take that major in the first place. But I think for me, I with all of the experiences that I've had at Berkeley, it's always been folks who are uplifting, folks who are trying to really help collaborate as opposed to compete with you, right? And there's a lot of individuals who are really like open to helping other individuals succeed, right? Especially with the upperclassmen that I've worked with, and I think that's what MET kind of helps out with, is being able to provide you with a pipeline for folks, for people that you can kind of go reach out to. For upperclassmen in general, like I found a lot of my upperclassmen to be incredibly helpful. Um, and kind of helping me navigate biotech, helping me navigate kind of what projects I wanted to work on, what classes I should take as a computational biologist, right? Um, Also giving me access to different opportunities, research opportunities, um, so on and so forth. And so I think that's a common misconception people have, is that, oh, Berkeley is like going to be very competitive, you're gonna always be like competing with your peers. No, not really. Like you're realistically going to be working with your peers, and you're going to be able to kind of work on projects together, you're going to find your people, um, so on and so forth. So I think that's something that I would say really struck me when I came to Berkeley, was that when I first kind of landed here, if you may, right? Everyone was so willing to help out. Everyone was so willing to say, "Hey, look, here are the projects that I'm working on, and here's how maybe you can help out with what we're doing," right? So on and so forth. So I think that really is something that adds adds to the whole experience, and that's something that really does kind of go away from that initial thought process that people have when they enter Berkeley versus when they exit.
Mhm. I'm pretty sure mostly it's because like everyone's talking about the club culture, so little spaces for these clubs, but there's so many people applying to the clubs. So
Absolutely. Absolutely. And I can see that a lot, right? There's consulting clubs on campus, there's like technical clubs on campus that have a pretty rigorous process. We oftentimes like joke that it's kind of like a mini um, college apps once you've already gotten into the college, because of how extensive the processes are. But I think part of that is because Berkeley is big, right? We just have so many people applying to the same roles. But part of that, I think, also gives a little bit more of kind of a real world experience to things, right? It gives you that perspective, right? Like when you get into these clubs, you're kind of sitting there going, okay, I just outcompeted like X amount of people to join that club. And yeah, I just said, hey, look, Berkeley is not about competition. And then I'm saying, hey, you outcompeted people. But like at the end of the day, like what I mean by that is like, I think you're not really competing with people as much as you are just like putting your best foot forward, right? And I think that's something where like it's just everyone does that, right? And that's something where like the competition is more uplifting than like negative competition that really comes through when people kind of often talk about competition, right? It's like there's that element of like, oh, this individual and you are also working together on projects, but you're also equally kind of motivating each other to go apply to uh, other projects or other clubs or otherwise, right? And so when you're applying to these consulting clubs and otherwise, you're basically just trying to find that personal brand. And I think that really helps with being at a bigger university where there's a lot of different individuals who may have similar brands to you. So you kind of keep going and you say, hey, look, here's how I can craft my unique niche. Oh wait, there's someone who's a little bit more similar, so let me go a little bit deeper and say, here's how I can better craft my personal brand. And so by the time you kind of go through that process, you've really built a pretty established brand for yourself of what interests you, right? What you're passionate about, and then what defines you. Why are you um, different from the next guy who's applying to that same role, right? And so those are like life skills. Those are things that are going to help you in the workforce. Those are things that are going to help you when you're applying to grad school, so on and so forth, right? And so being able to have that change in personal branding that happens over time, I think is very important.
Yeah, I really like that mindset shift. So, like, one more point, one large question about college itself. I know we're running
Mhm.
pretty long, but for anyone who's waiting for like all the biotech juicy stuff, we're gonna get to that a bit later. But I think
Mhm.
there's a huge question with like this whole education. Like, what does education mean to you? Like, for example, like, do you strive for like a 4.0 GPA, and do you try to have a like score full marks in all of your tests? Because I feel like there's this debate online or just personal experience where you learn a lot more just by doing like these actual like hands-on research and like actually being in the startup, right?
Mhm.
Compared to taking traditional classes. But obviously, last time you mentioned that there are definitely some Berkeley classes where there's like hands-on and they're using trending AI stuff to teach as well. So like
Yeah.
based on your experience, you have to take mandatory classes to fulfill some of the different parts for like the Berkeley requirements and stuff like that. So do you
Yep.
prioritize different classes and you don't want to achieve like full mark for some of them and you try to put more effort in these? How's your approach on all this?
So I think it's really shifted over the years, right? Like when I first started off, like um I think for me, it was very much so. I just want to learn, right? I just want to learn new concepts, learn new skills, and otherwise. But when I came into Berkeley, right, I was a little bit more focused on doing that learning through hands on projects and research and clubs and things like that. And then I realized eventually that, like, nothing beats like, nothing beats kind of doing it, learning especially from a theoretical and conceptual standpoint than your classes, right? So you need to be able to really understand that. I think with Berkeley and bioengineering, it's like it's not fully like out of scope to get a 4.0, right? But I do think that it's a little harder to be able to get that 4.0 at Berkeley. So for me, I mostly just prioritize being able to understand concepts, right? Being able to understand what it is that my professors are talking about, what it is that we're building towards, right? So on and so forth. And so ultimately, like kind of what I say to answer your question is what I recognize is that if a course really plays to my skill set, right, then I tend to look at that and go, okay, that's a course where I know I can reasonably put in
Mhm.
X amount of effort and I'll get X amount of results, right? So if I put in like, I'll get Y amount of results, right? So if I put in, let's say, I put in 10 hours, I can get 15 hours worth of results because it plays to my strengths. And so those 10 hours are pretty quality 10 hours. Whereas for someone else, it would require 15 hours to get 15 hours of results, right? Worth of results. Then I'd basically be like, okay, I'm going to kind of modify the way I'm approaching this class so that I try to use less time but still get the same level of results, right? Because it's playing to my strengths. But if it's a class where I know that the content of the class is something that's a little bit more involved, right? I try to allocate a little bit more time to that class so that I make sure that I understand the concepts. I make sure that the value that I'm getting out of that class, right, is representative and reflective of the amount of time I'm putting in, right? And so, for example, right, there are some classes that I'm taking this semester where like things like marketing, that's something that for me has been really interesting, but it's also something that I found that my skill set really translates well into, right? So I put in X amount of time, I get the results well, right? So I'm able to kind of go in and say, oh, we need a pitch deck done. I'll just lock in for 3 hours, get the pitch deck done and present that, and we're good to go, right? I don't have to spend more time than 3 hours that are necessary to finish that pitch deck. But and of course, like the same goes for articles or otherwise, right? The pitch deck is just one aspect of the class, but if I just like have that pitch deck done and the professor says, oh, this should take you about 3 hours, I can get that done in 3 hours and know that the value that I'm getting there is pretty much like going to be good value, right? Like I don't need to spend more than 3 hours for that because I know my skill set and what I'm interested in. But if I'm, for example, taking I'm also taking discrete mathematics and probability right now, and that's a class where it's definitely way more involved, right? There's a lot of proofs, there's a lot of math involved. You need to be able to understand what you're doing, and if you don't, then every proof compounds. So you need to be able. So then eventually you can get very behind very very quickly, right? And so that's a class where I'm saying, okay, I'm going to double the amount of time that I spend for this class, right? So if the professor says this assignment should only take you 3 hours, I'm going to make sure that I take the 3 hours to do the assignment, and then I'm going to take 3 hours to debrief what I'm understanding from that assignment, right? So I really go in and I sit down with the concepts and I go, here's what worked, here's what didn't work, here's what I still am confused by. And then I go into the lectures or I go into the lecture notes. Or one thing that I've been using, we were talking about systems, is I've been using NotebookLM and I feed it in my notes sheet and I say, hey, podcast this, right? And then NotebookLM now has this feature where you can have conversations with the podcasters, if you may. And so I ask them questions. I'm like, okay, so you talk to me about, for example, the law of large numbers, right? Tell me a little bit more about why this formula is using these specific notations, as opposed to like in statistics, where when we learn the law of large numbers, we learn it from a more conceptual standpoint, right? Here, we're actually defining a specific equation for it. Why are we doing that, right? Or why are we going and using a error bias? Or what in machine learning, right? You're understanding like convolutional neural networks, right? You want to be able to understand what each convolution layer does, right? So you then go into NotebookLM and you ask it, hey, what is the dimensions of this convolutional filter? What does it do? How can you apply that to biotech, right? And one of the examples that our professor gave was that you have this convolutional layer that basically adds a unique kind of uh, number encoding to each. Like you have this filter and you run it through a set of parameters, and you basically get an output score, right? And so you can kind of talk to NotebookLM about, give me an example of a real world project that allows you to do exactly that, right? That allows you to kind of test out the test out a real world example from end to end using that process in the middle. And so really been helpful to understand the concepts and to be able to go a little bit deeper. And that's kind of the type of things that I do in that extra 3 hours, to be able to really hone in and probe a little deeper into specific concepts that maybe I'm not grasping, or maybe are a little bit more vested in terms of things like that. So I think that's how I balance those classes.
Yeah. I think that goes back to the overall point of just honing on your strengths and weaknesses, because I think throughout the podcast, like you clearly see that you, Harvey, like you've actually like thought about like your strengths and weaknesses and what you like and what you don't like. And I think many people should do that, like approaching college, like literally in the micro level, on whether you like to watch videos and learn or use flashcards, like literally what system that you personally like. You shouldn't lie to yourself, so then you know what
Mhm.
classes to take. And I'm assuming that Berkeley also has like classes from different types, because I was like looking at like Stanford's classes for the summer, and they have so
Yeah.
many different things. Like um they have labs, right? And they have like seminars, and then you can like discussion sessions. They have just all sorts of classes. And I assume
Mhm.
for many of these classes, they also have like different exam types. And
Mhm.
also some of them are like exam based or like some essay based. So with like most of your courses, is it like mostly like exams, or is it just like writing, or what do you prefer?
It really depends on the course. Um, I know some of my courses are project based, so they do prioritize like a final project as opposed to a final exam. Some of them are final exam based. So it really depends on the course, the professor, and what you're trying to learn, right? Um, I think for a lot of the intro level courses, they're a lot more exam focused, really trying to test knowledge. So, like Introduction to Chemistry at Berkeley was very much so just 4 exams, right? And so you would kind of do every single exam for every single kind of component of what you were trying to learn in chemistry, and then that would kind of be your main source of kind of understanding that course, right? But the more you kind of go into the more niche classes, right? The ones that are a little bit more upper division, or classes that are a little bit more focused towards specific areas, right? You tend to kind of start seeing a little bit more of a prioritization to final projects as well as final exams. But the final project basically becomes more important, right? So I was recently taking a computational intro to computational biology, which was a course where we had one midterm, we had one final, but we had a final project that was really worth a lot, right? And that final project was enabling people to use the tools that we understood in class to be able to write a research paper on kind of how to apply those tools in such a way to a unique viral family of our interest, right? So we got a chance to. So our group ended up picking Pox viridae, which is like the smallpox viral family, and so we went a little deeper and used a genome browser to understand the different genomes. We compared them, we sequence aligned them, and then we even looked into at some point um, kind of how specific proteins and genes within those genomes dock. So like the protein basically creates a complex with some type of receptor, and so what we were able to kind of understand was as the viruses kind of evolved over time, did the binding mechanism change, right? And and if so, is that able for us to kind of be an indicator of the potential virality of those diseases? Because of course smallpox has been something that's incredibly virulent as a virus, but then you look at monkeypox and it's also virulent, but it's less so compared to smallpox, right? And then you look at things like cowpox and chickenpox that are a little bit less so than that, right? And so you kind of look at it going, smallpox was super, super damaging as a virus, but we're using kind of remnants of cowpox to actually be vaccines for smallpox, right? So how does that work, right? Is that because cowpox just has a different protein um, like structure, or is it because of something else that's underlying? So those were the types of questions that we asked, and then we kind of hone in on those questions a little bit more and go step by step to try to understand what's going on with using tools like AlphaFold or this genome browser or so on and so forth. And then from there, we were able to build out a very concrete research plan and then write a research paper. So those are frankly, the classes that really interest me the most because not only are you understanding the concepts, you're also going a step further and you're being able to apply those concepts to something meaningful that ends up being a research contribution or something that you can actually put towards a portfolio or towards a project in the future, right? Especially with side projects and entrepreneurial aspirations. Like these are the types of projects that end up being things that facilitate that. And so, actually, one of the projects that I'm working on right now is a project for a synthetic biology lab where we're looking to basically try to have ChatGPT communicate with Benchling, which is a pretty common software for uh, genome editing. And the idea is that if we could kind of connect these two platforms, then I can just be on ChatGPT, upload a file, and say, "Hey, can you annotate this file for me using what you can see in terms of genetic sets?" And I can even maybe put in and say, "Hey, look, I wanted to perform this specific experiment on these specific files. Can you walk me through step by step how to do that?" GPT walks me through, but it goes instead of going into Canvas like it normally does right now, where when writing emails or when writing code, right, it pops into Benchling and it says, "Oh, here's your plasmid, here's the different steps that we conducted, and here's the final result." And so that would be really cool, right? Because you're using GPT, but you're also getting a lot of value for it. And so that's something that I'm currently working towards. And that's a cool, fun project in a class that's more niche. And so that helps me build my technical depth. But I can also see myself building that a little bit further and maybe at one point starting a company based on it, right? And so that's something that is just super cool to be able to do and to be able to add value in that way to uh, just to a class, right? And so I think those are the types of classes that do exist, and they're definitely a little bit more fun in terms of end value.
Yeah, I think it's a really good segue towards talking about more on like the startup research and everything. But like a interesting question that is I think pretty challenging that came up in my mind is like with all of the experiments that you've done, have you ever thought about like particular things in biotech which cannot be represented with symbols and symbols by like experiments or like relationships? Because I don't know, I've been thinking like lately there like we're always surrounded by like math and all of these intellectual concepts where it's just all about measuring relationships and things can be measured, right? But
Mhm.
is there really a field where um you can't really explore the relationship or something because it's just so random? Like, what is your opinion on that? Like it's you could give it a think or something.
Yeah. I'm not particularly sure. I don't know. From what I've kind of learned in biotech, right? Like most things were representable. So I think to answer your question, I think one really interesting story was kind of in a class that I was taking called biological transport phenomena. And it was really interesting because we were working on understanding a couple of different factors, right? The course was about understanding diffusion, understanding flow, and then understanding reactions and how those reactions kind of are affected by diffusion and flow, right? And so when we were actually doing this for one of the like important parts of this course, we had to use an equation called the Navier-Stokes equation. Now, the Navier-Stokes equation doesn't actually have a existing solution. It and instead is currently unsolved, and I think like the prize money is like $1 million or something to solve this equation. Um, but basically, I kept asking to myself like, if the equation is unsolvable, then what are we doing here trying to solve it, right? Like,
Yeah.
give someone else the $1 million. Like, what are we doing, right? But it turns out, right, the way that the professor kind of allowed us to solve for Navier-Stokes was to basically simplify the equation by making certain constants, like by making certain variables constant, right? And then we would kind of be able to get a simplified version of that equation that we can then play around with and actually prove, right? And so kind of going to your point, right, I haven't really found anything where it's like symbols don't truly kind of represent the equations and otherwise, but I think this is the closest, right? Where the equation is unsolvable, but you're able to get something uh, that creates this kind of proxy type situation, and can kind of be close.
Mhm. Like in terms of value adding, like we talked a lot about value adding and the importance of that. That's literally what everyone is doing every single day, right? That's how
Mhm.
money happens as a currency and why we're here in the first place. So, what other metrics do you think there are for value adding other than like, adding personal data or adding data that you gathered from experiments that you see?
Mhm. So when you're talking about like metrics, are you talking about just like outputs, like results, or are you talking about like something a little bit different?
Probably more like strategies or processes that you see that adds value other than just performing experiments in like a high field when you're doing these research.
Sure, that makes sense. I think for me, value is quantified by um, personal value and by like kind of the value that you're creating to others, right? So from the personal value standpoint, right, what does value really mean, right? What am I talking about, right? So when we're performing an experiment, right, you get some level of personal value from that because you're like even if your experiment fails, right, you've learned something from that experiment, right? You've gained some insight into what failed and what you need to do in order to fix it. So if it, for example, right, like when I was talking about kind of that experience with GeneLab, where we were doing that project and we had to wait an hour, right? That was valuable time that we spent kind of figuring things out, making a plan, and then applying that, right? Um, and that was something where we kind of realized that there's a problem to be solved. We figured out how to solve it, and then we got some personal value in the process because we were able to understand, oh, for next time, maybe this whole parallelization strategy works better, right? Because we were able to really work faster. We were able to be way more efficient. We had two people working at the same time, and we could deliver twice as fast, right? And overall that really worked in our favor because we had a bunch of hiccups along the way, right? Like it wasn't a smooth process by which to perform all of these analyses. We definitely had our fair share of challenges and things that we needed to get fixed, but because we had two people kind of working on it, right, at the same time, we could kind of go to our research mentor and be like, okay, how do I solve it for one of them, right? Because the other person, all they have to do is do the exact same steps, but on the other's data set, right? And so it gave us this ability of being able to work faster and work more smoothly. And we learned so much from that experience, right? Now, what was the actual impact of that, right? This is personal value, but what was the impact? How do you quantify that metric, right? Well, the impact was the research paper that we actually produced, right? Was the presentation we actually got a chance to present, and that was something where we took everything that we learned, right, across these experiments, and we designed a new one, right? And we said, hey, look, here's what we think is the underlying key factor that's causing these issues. So let me actually talk a little bit more about what we did, right? So we were looking at a NASA data set called GLDS 238. Um, it's being housed by NASA's GeneLab data repository. GeneLab houses a lot of NASA's genetic information on mice that were flown up into space to test radiation and microgravity conditions, right? And so the GLDS 238 was an interesting experiment where they were testing for the effects of diet on and microgravity on the gut microbiome and inflammation pathways. And so we got a chance to look at how these sugars called beta fructooligosaccharides would be used in diet in order to potentially curb different effects, right? And so what we found was that we were doing an analysis. We performed differential gene expression, and once we did all of that, we found that there were really some really interesting patterns that emerged, right? One was the idea that there were collagen genes that were being downregulated. And that was really interesting. We were kind of looking at that from the standpoint of traditionally those same collagen genes have been upregulated in spaceflight. Now, what does downregulation and upregulation mean? Well, for those of you who don't know the terminology, right? It's the idea of almost like a switch, right? You're turning the switch on to produce more of something, that's upregulation. You're turning the switch off to produce less of something, that's downregulation, right? And so we've noticed that those collagen genes were being downregulated. Now, when we went and did a literature review and we looked at all other sources of kind of what happens in radiation and microgravity based off of those collagen genes, what we found was pretty interesting. It was the fact that most of those collagen genes were actually being upregulated. And it went to a point where we were actually reading some of NASA's twin study experiments, which are really popular. There's something that made headlines and the news several times in 2019, and we were reading through some of their docs for kind of looking at clues for what we can understand from these collagen downregulations, and we found that the collagen was again being upregulated in that spaceflight experiment. But it was really interesting because they were kind of mentioning that, the astronaut did not have anything else supplemented in their diet to be able to do that, and potentially diet could be the key, right? And so it was really interesting to be able to kind of recognize that, hey, maybe we stumbled here on something that's kind of pretty cool, right? And so that was kind of the fundamental of our research paper, was understanding um, that hey, these beta fructooligosaccharides seem to be doing something really cool where they're bringing collagen levels back to baseline. But then that doesn't really tell you what the impact is for a bunch of astronauts in the long run, right? Like, where does collagen fall into place? What does it do? How does it help? So that's where you kind of answering your question. You look at other metrics, right? And so what we did was we looked at the pathways that these collagen genes were a part of, and that's where it was really struck us as really as interesting, because the pathways that they were part of were pathways that were part of potential skin cancer risks and wound healing risks, right? So if you were to get a nick or scratch in space, it may be affected differently than it was on Earth. And so what we found was that these fructooligosaccharides were actually helping to to promote wound healing a little bit, and to basically act as an anti-inflammatory substance in space. And and that was really interesting. So we managed to kind of write a research paper around that. But then we also went a step further to say, well, is are beta fructose oligosaccharides used in kind of the uh, like the confines of Earth? And it turns out it is in foods that are traditionally um, found to be anti-inflammatory. And so it kind of validated a little bit of the idea that, hey, look, anti-inflammatory foods here can also be used in space, but they can have a little bit more of a profound effect in space. And so we designed an experiment to validate all of those conditions, right? We said, okay, we have this hypothesis that beta fructooligosaccharides work for these types of um, dietary restrictions and conditions. Is there a way for us to validate that even further? Here's a potential experiment that we can design. And so we designed that experiment, we sent it out to NASA, they liked it. So they brought us out to present to a research conference called the American Society for Gravitational and Space Research. And then from there, we kind of even got a chance to work with a couple of researchers to continue the research across different types of data sets and publish a paper in the field that ended up getting submitted to Nature Communications and was recently published in their June article for 2024, right? And so, like, just being a part of that process from end to end really taught me a lot personally in terms of personal value, but it also taught a lot about what types of metrics are important to people and how you can really translate those metrics into saying, here's how we can create real world impact based off of the research that we're doing. And I think more and more what we're seeing is that a lot of startups are being spun out of research projects. And the reason for that is because a lot of the value that could be created to customers can come from selling to customers rather than just kind of building theoretical applications, right? And so what we're seeing is like, you know, with Berkeley's very own like Jennifer Doudna, that's what she did, where she understood CRISPR, but then she was like, look, I want to start a company to actually make CRISPR mass market. And so she along with her two like grad students helped form Caribou Biosciences and Mammoth Biosciences and so on. And so those are all now kind of companies that are within her portfolio where they're all using CRISPR to create some really cool, effective therapeutics in the process.
Mhm. I'm not gonna pretend that I understood all the stuff that you're saying, but definitely like I love the things that you're saying. It's super interesting. So like, could you give us a rough outline on what you see biotech dominating or what you see biotech bringing us in the next 5 years, like based on all of the research and everything that you've been looking
Mhm.
at on your picking your brain here?
For sure. I mean, I think it really depends on which type of biotech you're referring to. Biotech itself, I think, is a really cool word because it means so much to different people, and it's really a thing about perspectives. So, a friend of mine currently is doing a lot of biomedical device work, and he actually is a part of a company that's building these little handheld devices for fetal monitoring. And I personally think the company is inherently cool, so I wanted to shout them out. But they're basically building these devices for fetal monitoring for parents who might be a little bit nervous about their kids, for new parents, so on and so forth. They built these jaundice monitoring softwares as well in a handheld configuration to be used non-invasively. And then now they're working with endometriosis, which is something that hasn't historically um, been treated by non-invasive methods, right? Or minimally invasive methods. And so like that sort of thing is really cool. Like a lot of devices I'm seeing is a pretty big trend that that's kind of going on right now, where we're seeing a lot of device companies leverage AI to be able to kind of create some really unique insights. There was another company that I got a chance to look at that was building a AI layer on top of ultrasounds to be able to analyze another like pregnancy monitoring software, but it was pretty interesting because they were basically building this AI system to help doctors detect like certain certain conditions in a baby. So, for example, if like the baby had the umbilical cord wrapped around like specific parts of their body, it could cut specific blood flow to those parts of the body, right? So it's really dangerous for a baby. And so being able to, you normally detect that through ultrasound. So being able to like spot all of that really quickly using AI was something that I thought was really valuable. Now, on the therapeutics end, like a lot of a very common thread or trend rather that's being exhibited is kind of the idea that everyone is using AI for drug discovery, and that's really helping a lot of the R&D costs, right? So now what we're seeing is that we're seeing all of these companies kind of come in and say, oh, we're leveraging AI, we're finding our specific drug targets by scraping a bunch of uh, patient information from NCBI, from NIH, from all of these different sources, right? And then they basically take all of those, they run it through an AI process, and then they're able to spit out specific targets for specific diseases. And this was actually something that I was working on as a intern for my freshman summer, where we were building a query tool to actually design understand the NCBI database. And so we looked at patient data, and we were able to kind of identify extract all of those patient data from research papers that were being published, where we were kind of like, oh, these are the number of patients that were healthy, these were the number of the patients that were unhealthy, and these were the conditions that were exhibited. And then the company basically had designed a AI tech stack that they were using to basically take in all of that data and then output potential receptors that would be interesting for those patients, right? And so what we found was that there were actually two receptors. One was the one that we were kind of identifying, which was this receptor called the tweak receptor that could be used for treating ulcerative colitis. And so that was a really cool find for us, because we were kind of looking at the fact that we could create this query tool that takes in all of this information, pre-processes it, sends it into the AI system, and it outputs a specific receptor. And then if we were a pharmaceutical company, or if we had pharmaceutical inclinations, then that would be something that our company would take in and start building drugs for. But we rather were selling to a pharmaceutical company, so this was information that we gave to that pharmaceutical company to be able to actually use for their own personal benefit. So that was kind of something really cool, because you're looking at it from the standpoint of everyone is now leveraging AI to build a lot of really cool technologies. There was also that project that I was mentioning earlier about ChatGPT with Benchling. That's another project that you're starting to see a lot of folks use, kind of integration with GPT. There was a really cool LLM model called Evo 2 that came out of Berkeley, Berkeley's ARC Institute to be very specific. And that's almost serving kind of like a nucleotide engine. It was trained on all of these like unique nucleotides, and it's basically to the point where it can even kind of generate its own nucleotide sequences based off of information you provide. So if you, for example, like theoretically, people were saying that if you were to just say, hey, look, you type out, I want to build a nucleotide sequence where I use like very heavy amounts of nitrogen as opposed to carbon as the main element, could you theoretically do that, right? The idea is that Evo 2 could potentially kind of look into doing things like that in the future and looking for signs of life, or helping us to better understand what constitutes life, right? Just by giving us a better understanding of what constitutes genetic information and and some of these data sets. So it was just a really cool paper to read. And so those are like trends that I'm noticing where we're leveraging AI techniques, we're leveraging these computational techniques, and we're also leveraging kind of these understanding our understanding of devices to basically innovate in three different spaces within biotech.
Mhm. I mean, with this development, do you think we're gonna hit a tipping point? Because like I think going back to like the overall point of like I keep thinking about like origins and history, right? Like
Mhm.
originally there wasn't AI, there wasn't technology, everything did not have interventions with humans. Do you think that we're gonna get to a point where it's just gonna topple over, or do you
AI
not believe
itself, um, not sure.
by
Oh, with bio,
yeah.
with biotech in general, I think like see it's different, right? Like I think with AI, there could be a potential tipping point at some point. With biotech, I think look at the end of the day, like we've seen tremendous history with bio, right? Like you know, only just about 100 years ago, or actually no, a little bit more than that, like about 150 years ago, did we actually recognize that DNA is double stranded, and then from there, everything that we know about biology with regards to genetics and genomics has come within the past couple decades, right? And so it's like it's inherently fascinating how much we've been able to grow from there, and I think that trajectory is not going to stop, right? I think technology is just going to help us accelerate that, right? We're going to learn a lot more. We're going to be able to um, find more insights, and that's what we're seeing, right? Like from CRISPR, we're seeing we're seeing new papers be published where like there's this whole idea of uh, ribose switches, which is kind of these little um, self-cleaving enzymes that can work almost like different switches. And actually, one of the projects that we had for one of our classes was to understand how these ribose switches work to logic gate, right? And so we could create an and ribose switch, or we could create an or ribose switch, or a not ribose switch. And this is something that is really interesting because then it kind of begs the question, well, if you put those logic gates together, can you create something a little bit more uh, similar to like a logic circuit? And if you can create a logic circuit, can you create a biological computer? But then why would you want to create a biological computer? What is the value that that could have, right? And is there any value? And then it kind of begs more questions of like time dependencies and speed, right? Is it faster to use a chemical gradient or an electrical gradient, right? And then recently there was actually an article that I read where someone was using a neuron as a computer, and they were using the action potentials to dictate electrical signals, right? And that's something where you're kind of looking at that going, is that kind of something that in the future is going to be more widespread, where we kind of integrate biotech with traditional tech, right? And so I don't think biotech is going to stop anytime soon. Like I think I don't know. Frankly, I can't really predict if there's going to be a tipping point. But from what I can see, like we're kind of always innovating in the space, and we're always adding. And um, there's also so much of technology is kind of integrated within biotech across the spectrum, whether you're working in devices, tissue engineering, or just regular genetics and genomics. And so across that spectrum, I don't think we're stopping anytime soon yet.
Awesome. I think we're having a really great conversation, to be honest. We dive really deep into stuff. So just like going back to the overall plan, I remember last time you told me that you're going to be diving more into like this biotech startup or the VC space more. So what's the plan for or the vision with biotech for the next 5, 10 years that you're going to be working on?
Absolutely. I think for me, I definitely want to continue building my skill set in biotech. So for me, startups are definitely something that I'm looking into. I'm also looking into kind of pharmaceuticals and some of the bigger name institutions as a way to just gain skills and understand how they perform their R&D pipelines. And then from there, kind of the long-term vision is potentially build something of my own or join a venture firm and help kind of other people build something of their own. But I think that part is still up in the air. It really depends on how much skills I can create and how much value I can produce, right? But right now, I think where I'm at is being able to build um, technical skills and technical depth in biotech, and then also be able to kind of leverage my business degree to add value to others who are also working in the space.
Awesome. I mean, how many hours of sleep do you normally
But
get?
yeah. Wait, sorry, could you repeat the question?
Yeah, how many hours of sleep do you normally get?
Normally about 8 hours, seven if I need a little bit extra time to go work on things, but normally 8 hours of sleep. Yeah.
Yeah,
It's
that's
pretty
pretty solid.
uncommon like to hear that from a college student, definitely, because um I think most college students are like, oh, we have a really weird sleep schedule. But what I've tried to do is I try to, like, even if I don't sleep all the time, like in the night, right? I try to make sure that I allocate some time throughout the day for me to just come in and take quick naps, because I've noticed that sleep is very important to just kind of functioning at a high level throughout the day. And so I try to reach 8 hours of sleep every day, at, or at the very least, try to get like a couple of naps in throughout the day to make sure that I'm energized and ready to tackle the rest of the day.
Mhm. I think it's a really nice way to end the podcast. Or if one day there's going to be some kind of biotech that's going to make us not need to sleep.
Augment sleep. I'd be really happy for that day. That would be awesome.
But yeah, I'm going to link everything for anyone who wants to contact you, Hari. I think this is one of the best podcasts, to be honest, that we've had on the Gen Z Fastlane. So I'm pretty happy about that. And yeah, I mean, I'm wishing you all the best and peace
Absolutely.
out.
Thank you so much, Bosco. Really appreciate the time.